Okay, I'm going to start doing the homework from 6.1.2. This is the second time around, just to make it a little bit more clear. Okay, 615 says to solve for y using your own steps. So we want to get y alone. So what we will do is we will subtract 8x from both sides. And that will yield 4y, which is now alone, is equal to negative 8x plus 2. It's always a good idea to make sure that you understand what happened there. I subtracted 8x from both sides, so we got that. Now, of course, I'm trying to get y alone, so y is nearly alone. I just need to divide by 4 now. So I divide 4 both sides, and I get y equals negative 8x divided by 4 will be negative 2x, and then it's plus 2 divided by 4. 2 divided by 4 is 2 over 4, which is best written as 1/2 or 0.5 if you want. Sides, not size. Okay, there you go. That's it. Solved for y. Done. Okay, let's look at this example. We want to get y alone, so the first thing we're going to do is get rid of this 12x, and I'll get rid of it by subtracting it. And what that'll get us is negative 3y is equal to negative 12x plus 7. As we subtracted 12x on both sides. Now we're going to divide by negative 3 on both sides. Let's divide negative 3 both sides, which yields y equals negative 12 divided by negative 3 to negative divided by negative, so it would be 4x plus, well, we have 7 divided by negative 3, so it's a positive divided by negative, so it's actually minus 7 over 3. We'll keep that in parentheses just to make sure it's understood what's happening. It's a positive 7 divided by negative 3, that's why it's negative, okay. 616, solve each equation for the variable. Check your solutions if possible. Okay, we want to get a alone here. So the first thing we're going to do here is combine like terms. We have 8a plus a, so that's going to be 9a minus 3 equals, here we have 6a minus 2a, so that'll be 4a minus 3. I'm going to add 3 to both sides. If I add 3 to both sides, these minus 3's will disappear, and I'll have 9a equals 4a. Get all the a's on the same side, so I'll subtract 4a from both sides. I get 5a equals 0. I'll divide by 5 on both sides. A equals 0. If I know that a equals 0, I can plug it back into the beginning equation to see if that actually does work. So every place where I see an a here, I'm going to replace it with a 0 and see if this equation comes out true. So 8 times 0 is 0, 0 plus 0 is 0, 0 minus 3 is negative 3, equals 6 times 0 is 0, minus 2 times 0 is 0, so 0 minus 0 is 0 minus 3. This is true, so a must be 0, so I solved it correctly. Good. Alright, let's look at b. B seems like we got to do the distributive property, but I noticed something here. What I see in the parentheses here, parentheses m plus 2, is exactly what I see here, parentheses m plus 2. So I realized that that can actually be divided out from both sides. So I'm going to divide both sides. I'll write out my steps so you can see. I'm going to divide by m plus 2 on both sides, which yields just the old m plus 3 from the left side, close parentheses, is equal to m minus 2 from the right side. This is equal to this, so we got that. Now I'll subtract 3 from both sides. Again, the idea is just to get the variable alone, so subtracting 3 should work pretty well. That leaves m on the left side equals m minus 5 on the right side because I subtracted 3 from both sides. Now I'll just subtract m from both sides. Why not? And what that gets us is 0 equals negative 5. And you're like, no, 0 does not equal negative 5. And that's true. That is never actually true. So what we actually have here is no solution, ... No solution, because 0 can never equal negative 5. So in other words, this entire equation B is not possible. Okay, C. I want to get x alone, so the first thing we gotta do is get rid of that 1. We'll subtract 1 from both sides, and that yields x over 2 equals 5. So now the x is nearly alone, but we need to undo the division. It's being divided by 2, so we're going to multiply both sides by 2. And what that gets us is x divided by 2. When we multiply it by 2, we're just left with x. We've got to do that by 2 on both sides, so the 5 times 2 is 10. X equals 10, done. Let's prove that's correct though. I'm going to put a 10 where I see the x and see if that's true. So 10 divided by 2. 10 divided by 2 is 5. 5 plus 1 is 6. It is true, so my answer is correct. X equals 10. Good, good, good. Okay, next D. It looks pretty messy. It says 4t minus 2 plus t squared equals 6 plus t squared. But what I notice is that I have plus t squared on both sides. If I get rid of that, it'll be a lot simpler. So I'm going to subtract. Hold on. Be patient. I'm sure you see the reconnecting there. I'm going to subtract. Let's get back to a full-size font here. So one way to get back to a full-size font if you're stuck with an exponential font is just copy something else and then just type over. It's lazy. There's other ways to do it. Subtract t squared both sides. The reason I kept the equal sign in there is because I wanted the full-size font, so I wouldn't have to undo the superscript. Both sides, what does that give us? It gives us 4t minus 2, this t squared is gone, is equal to 6. So now it's simple. We'll just add 2 to both sides, and that will yield 4t is equal to 8. Divide by 4 on both sides. And that will give us t equals 2. Okay, so we want to be sure that's true, so we'll plug it back in. That means everywhere I see a t, I'll replace it with a 2, and it should come out true. So instead of 4t, we're going to say 4 times 2. Instead of saying t squared, we're going to say 2 squared. And instead of saying t squared here, we're going to say 2 squared here. Alright, so let's work this out. 4 times 2 is 8. Oh, I just blew my own mistake. Again, I'm not copying the equal sign for the equal sign, I'm copying it for the font size. 8 minus 2 plus 2 squared is 4 equals 6 plus 2 squared is 4. Let's keep working on this. What is 8 minus 2? 8 minus 2 is 6. What is 6 plus 4? 10. Equals 6 plus 4, which is 10. It's a true statement. That means our solution is correct. Alright, great. The last one we've got is 617. What is the missing term in this sequence? We're going to look for a pattern. Well, what I'm going to do is I'm going to go to Desmos. And I'm going to plot both of these. And then I am going to... I'm going to plot this, and I am going to look for a pattern that tells me this one. So I can do an LSRL. If you remember, that's Y1 toothpaste MX1 plus B. But anyway, we'll put these into a table. So here we are at desmos.com. Dun, dun, dun. Launch calculator. And just to remind myself, my X values will be 1, 5, 10, and 23. So here I am at a table. 1, 5, 10, 23. And my Y values will be 1, -7, -17, and blank. 1, -7, -17, and blank. And so far we don't see much. Let's scroll out so we can see it. Oh, there they are. Okay. So it does make a straight line. So we're going to get some sort of linear equation here. And if I want to find out what it is, I can just do Y1 toothpaste MX1 plus B. And somehow try to make a 1, and that came up. That's what I wanted. Alright, so that hit really well. You see how the lines all lined up there? So then I'll just go to my X equals 23. And I can figure out what I've got here. So my X equals 23, -43. And it's always a good idea to plot it. See how it lines perfectly on the line? It means it's definitely the solution. So the answer is -43. Pretty solid, pretty straightforward. Okay, hopefully this worked for you.